Okay, basically in Bohmian interpretation, what is happening? The wave exists. Waves exist. And these pilot waves are handling the particles. So particle is still particle in one place, basically
floating.
one specific place, yes, and the wave is moving it.
Yeah,
Exactly, like something on the water. But there are fundamental problems with this Bohmian interpretation because still the particle should have a place, exact place on the wave, but exact place. And this cannot interpret many issues or many basically strange outcomes of quantum mechanics. Because still it has a wave, and the next question is, what is this wave? What we define in QTT is totally different. We say,
they call it de Broglie wave. They don't talk about substance. It's
yes,
de Broglie wave.
exactly. What we say is that basically Fabricas creating the wave in a hand-shaken system, and we call it BARPA, and this represents one specific time, one specific location, and one specific reality. So this is the wave of reality and a specific time and a specific location. This way. Now, basically, because it is one place, actually that particle, it is in a place, in certain place, still in a certain place, but that you use the word subspace, I like it, but still we are not exactly like in a subspace. But in a subspace, in all of that subspace, which is way larger than one basically quanta of a space which we call Fabrica. Because a lot of Fabricas handshake until they formatted that way, formatted that system. And that BARPA system will collapse as soon as we impose a reality by an observer to it. As soon as we watch it, it will collapse because the reality is one of the dimensions. And therefore we took an information out of the system, therefore it should be in one Fabrica, or basically a normal without handshake, like the system, BARPA system without any handshake with any other thing. Basically what will happen, we will find a particle here. But it is our eyes, our observation, that we cannot understand this was the whole space and a system, and we collapsed it into the smaller shrink. We shrinked it into the smaller, basically, space. The particle was there, but we see it was everywhere. It was not everywhere. It was in a BARPA system, which represents same time and same place, but in eyes of us, it's way bigger, way larger. But it is actually handling the same particle. Now, this particle can be anything. Can be photon, can be like electron, can be, basically other things. Now, what will happen if we put a force, like particles like electromagnetic or other things, basically that, or a strong force or weak force? Still, that basically field, while we are not calling it field, creates by BARPA system. So electron is everywhere around atom, right? What that means, even if it is everywhere around the atom, the weight of the atom should be very, like the mass of the atom should be bigger. For sure, they calculated that electron has mass,
Small ones.
A small mass, but still, if it is everywhere around atom, what will happen to the mass? But with this Barbour system, we can exactly clarify it. The whole basically field around the proton is one Barbour, is one place. It is one place, one time, and then when we observe the electron, it will collapse. When we observe the electron, for like that moment exactly. And then this Barbour system will change. That's why when we shoot something into electron can change the phase, because the Barbour systems that creates, they have like their own energy. They will handle their own basically energy, model, field, shape. Everything will be different in each Barbour system. But whole system created based on Fabrica, because in that case we can completely explain double slit experiment totally with logic. This is logical, right? Because it is the same space and time, and at the same time, what we can do, we can actually explain double slit quantum errors. Now let's actually watch something else as well. Okay.